This is a Cambridge IGCSE Chemistry Paper 2 multiple choice talk through from the year 2021. Which row about a change of state is correct? Let's first of all check the change of states and the processes. So solid to liquid is melting, but is the energy change heat given out? No. Gas to liquid, that's definitely not evaporation. That would be the opposite way round. What about solid to gas? It definitely is sublimation. Is heat taken in? Yes, it is. So that's why C is the correct answer here. And then liquid to solid, part D, is that condensing? No, it's really not. Gases are separated from liquid air by fractional distillation. The boiling point of 4 gases are shown, which gas is both monatomic and a liquid at minus 200 degrees Celsius. So monatomic means made up of one atom, as opposed to diatomic, which is 2 atoms, which is why we can discount nitrogen immediately, because remember, it's N2. Then we now need to consider the other 3 options, which are all noble gases, which is why they are all monatomic. Let's think about the boiling point. We need a liquid at minus 200 degrees Celsius. When the temperature increases to minus 186 degrees Celsius, argon turns into a gas, but when it's colder at minus 200, it's still a liquid, which is why A is the answer here. Both helium and neon would have been gases way before minus 200 degrees Celsius. 3. 2 different food colourings, X and Y, are tested using chromatography. 3 pure dyes, 1, 2, 3 are also tested. The chromatogram is shown. Which statements are correct? X and Y both contain 2 or more dyes. You can count them. Look, X contains 3 dyes, Y contains 2 dyes, so that's certainly true. Dyes 2 and 3 are present in both X and Y. Let's change colour to show you this. So here's dye 2, yes, it's present in X and Y. Here's dye 3, yes, it's present in X and Y, so that's also correct. The RF value of dye 1, so this dye here, is 0.625. To work that out, you want to use your ruler. I can't do this on the iPad. Let's call that X. Find that number, then measure the distance moved by the solvent front. Let's call that Y. So the RF value in this case is X divided by Y. And once you've worked that out, you should get a value which is very close to 0.625, which means that option C, 1, 2, and 3 are all correct. Which statement about the atoms of all isotopes of carbon is correct? So remember, isotopes are atoms of an element with the same number of protons, but different mass numbers, because they have different numbers of neutrons. So they're all radioactive. That's not true. Carbon-12 is not radioactive. They have the same mass. No, that's not true, because they have different numbers of neutrons. They have the same number of neutrons. I keep saying that they have different numbers of neutrons, so that's not true. They have the same number of electrons in the outer shell. Yeah, because they're all neutral, it means that if they have the same number of protons, by definition, they must have the same number of electrons to counterbalance that positive charge from the protons. So the answer here is D. Which diagram represents the structure of silicon 4 oxide? You do need to be able to recognise these things. A is likely to be diamond. All those atoms are the same. B is likely to be graphite. C is a curved ball and is likely to be sodium chloride, which isn't even a giant covalent structure. Option D is silicon 4 oxide. It looks very like diamond, but look, you've got different elements being represented by the different colours, the grey and the black, to represent silicon and oxygen. Lithium and fluorine react to form lithium fluoride. A student writes 3 statements about the reaction. Lithium atoms lose an electron when they react. That's true, because lithium is in group 1, so therefore it will choose to lose an electron to have a full outer shell. Each fluoride ion has 1 more electron than a fluoride atom. Again, that's true, because the fluoride ion is F-. Remember, it's in group 7, so it will gain an electron. Lithium fluoride is a mixture of elements. That's wrong. It's not a mixture, it's a compound. These questions are quite detailed, so the answer here is 1 and 2 only are correct, 6A. How many electrons are used to form covalent bonds in a molecule of methanol? For me, the easiest way to do this is to actually draw it. So let's label our atoms. add our electrons. So now everything has a full outer shell. So what about the covalent bonds? Count the electrons. 2, 4, 6, 8, 10. You're only counting the electrons in the overlapping portions. So that's why D is the correct answer here. Magnesium oxide has a high melting point. Carbon dioxide has a low melting point. Which row identifies the attractive forces that are broken when these compounds are melted? So magnesium oxide, remember, is a giant ionic structure. It's made up of ions. There are no molecules in magnesium oxide, which is why we can discount A and B immediately. These two are both looking good for C and D. What about carbon dioxide? Well, it's a simple molecular structure. So, as the name suggests, it's made of molecules with weak intermolecular forces between the molecules. So if we look down here, we do not like this answer because it mentions atoms. We have weak attractions between molecules. So 8D is correct. The ionic equation for the formation of oxygen during the electrolysis of aluminium oxide is shown. What are the values of X and Y? So let's sort this out ourselves. Start by balancing the number of oxygens you have. So you need a big 2 here. And then how many electrons do you need to add on the right-hand side? Well, 2 times 2 is 4. So the answer here is 2 and 4, D. A compound has a formula XF2 and a relative mass of 70. What is element X? So we know we have fluorine, which has an AR of 19. So F2 is therefore 38. So do 70 minus 38 to find the AR of X to get 32. And now we need an element that has an AR of 32. Look, it's over here, it's sulfur. So 10C is the correct answer. The diagram shows a section of an overhead power cable. Which statement explains why a particular substance is used? So power cable means it needs to transmit or conduct electricity. Steel, remember, is an alloy of iron. It's very strong, but it is susceptible to rust. Ceramic is a strong substance holding the aluminium steel cable in place. Aluminium has a low density and is a good conductor. So which statement explains why a particular substance is used? Actually, I've just said A. Aluminium has a low density and is a good conductor of electricity. What about the other options? Ceramic is a good conductor of electricity. No, that's just supporting the power stable. We don't want our electricity flowing through there, so that's not correct. Steel can rust in damp air. It's true, but why would that be a good thing here? Steel is more dense than aluminium. Again, that's true, but why would that be an advantageous property here? The answer here is A. During the electrolysis of dilute sulfuric acid, hydrogen is collected at the cathode. Remember, this is the negative electrode. What is the ionic half equation for this reaction? So we have hydrogen ions forming hydrogen molecules. Get that balanced and add 2 electrons to show the reduction reaction taking place. Have a look down here. Which one does it match up with? It's C. Which row describes an endothermic reaction? Remember, our energy change is positive. So what does that mean? It means that our products have more energy than our reactants. So as you have a look down here, that's not being shown in this diagram. It is being shown here. So now we need to pick between B and C. Remember, with endothermic reactions, energy is transferred from the surroundings to the reaction. It is not transferred from the reaction to the surroundings. The equation for the complete combustion of methane is shown. The bond energies are shown in the table. What is the energy change for the reaction? So energy change is given by the equation bonds broken in the reactants minus bonds formed in the products. So let's have a look at the bonds broken. It's this side. Just to show you the bonds being broken, there's our methane. So hopefully you can see there are 4 CH bonds, so we're doing 4 times 410. And then what about the oxygen? We've been told there's 2 of them, so we're doing 2 times 496. Add those up to get 2632. So there's our bonds broken. What about the bonds formed? We've got carbon dioxide. So that's 2 O double bond C's. And then finally water here. Count the number of bonds, it's actually 4 OH bonds. So do that calculation to get 3,450. So your final calculation is 2,632 minus 3,450 to get a final answer of minus 818 kJ per mole. Hydrogen fuel cells can be used to power cars. Which statements about fuel cells are correct? The balance equation for the reaction is this. Check. You've got 1 oxygen on the right-hand side, 2 on the left, so that's an incorrect equation. The fuel cell generates electricity, true. In the fuel cell, hydrogen is reduced, that's false. And then the reactants are gases at room temperature, that's true. 2 and 4 are correct. The apparatus shown is used to measure the rate of reaction. Which equation represents a reaction where the rate can be measured using this apparatus? So the way this is going to work is a gas is going to be released and you can measure its volume per unit time using the gas syringe, which means we need a product that's in its gaseous state. And actually, if you have a look down here, it's only hydrogen that is. So that's actually quite a quick question. P is a hydrated metal salt with a blue colour. When P is heated, water is given off, leaving solid Q. R is a hydrated metal salt with a pink colour. When R is heated, water is given off, giving solid S. What is the name of P and the colour of S? This is the chemical test for water. So we have hydrated copper sulfate here, which when it's heated and the water's given off turns white because it's now anhydrous. So we're picking between C and D. But what is the colour of S? Well, anhydrous copper chloride is blue and turns pink with water. So the colour we're looking for the original substance is blue. Magnesium reacts with copper oxide to give magnesium oxide and copper. Which substance is the oxidizing agent in this reaction? Remember, by definition, the substance acting as the oxidizing agent is reduced, which means it loses oxygen. The easiest way to answer this is by writing a balanced symbol equation to show what's happening. So you need to ask yourself, which of these substances is reduced, which one loses oxygen? Hopefully you can see that that's the copper oxide. Part of the periodic table is shown. Which element forms an acidic oxide? You're looking for a non-metal that will react, which is why it's B rather than D, because remember D is the noble gases, they're very unreactive. When aqueous sodium hydroxide is added to a solution of a metal ion, a grey-green precipitate forms which dissolves in excess to form a dark green solution. What is the identity of this metal ion? Unfortunately, these ion tests are just something you're going to have to learn the colour of, and it's actually chromium 3. Which statements about strong acids are correct? So remember that strong acids fully dissociate into ions and that they have a very low pH, and an acid is a proton, an H+ donor. So number 1, they have a high concentration of hydroxide ions. False. That's an alkali or a base. They have a pH value of 1. Yep, true. They completely ionize in water. Ionization and dissociation are the same thing, so that's true. They turn red litmus paper blue. No. Again, that's what a base does. So we've ticked 2 and 3, so answer C is correct. Metal X reacts with non-metal Y to form an ionic compound with the formula X2Y. Which statements are correct? So for this to hold true, the original ions must have been 1 plus and Y2 minus. Why? Because we need 2 X's for every Y. Now how do you get an ion with a 1 plus charge? Well, you need a group 1 metal because it loses 1 electron to get a full outer shell. And to have a Y2 minus ion, you need a group 6 non-metal because they're gaining 2 electrons to have a full outer shell. So which statements are correct? X is in group 1. Yep, I've already said that. X is in group 2. Nope. Y is in group 6. Yes. Y is in group 7. No. So 1 and 3 are correct, which means A is the right answer. The table gives some properties of group 4 elements. Which row describes the properties of silicon? So we want an intermediate density and a boiling point which is lower than carbon, higher than germanium. So actually that's option A. The metal beryllium does not react with cold water. So it's not super reactive because remember it's the group 1 elements that like reacting with cold water. It reacts with hydrochloric acid but it cannot be extracted from its ore by using carbon. So the fact it reacts with hydrochloric acid means it's more reactive than hydrogen, but the fact that it can't be extracted by using carbon means that it's more reactive than carbon. And so where are we placing beryllium in the reactivity series? Definitely not down here. It would be way too unreactive. It's worth learning the reactivity series, which goes something like this. Magnesium is more reactive than aluminium. Then we've got carbon, zinc, iron, lead, hydrogen, copper. So we've said it needs to be more reactive than carbon and more reactive than hydrogen. So we're looking up here. So it's actually A. Why is cryolite used in the extraction of aluminium from bauxite? It actually helps to lower the melting point of aluminium oxide because it acts as a solvent to help it dissolve. Which statements about the uses of metals are correct? Iron is used to make aircraft because it has low density. No, iron's pretty heavy. It's quite a high density and it's not used to make aircraft for that reason. Copper is used to make electric cables because copper is a good conductor of electricity. True. Aluminium is used to make brass because aluminium is strong and hard. No, brass doesn't contain aluminium. Brass contains copper and zinc. Iron is mixed with additives to make an alloy used in a chemical plant. Yes. It's often mixed with a bit of carbon to make steel. So we've ticked 2 and 4, option D. Which row describes the reactions of magnesium hydroxide and magnesium oxide? Remember that magnesium is more reactive than carbon. And so because of that, you'd expect no reaction because there's no way that the carbon can displace the oxygen. Then it's a matter of remembering the effect of heating on the magnesium hydroxide and it actually forms magnesium oxide. So B. The properties of an element are listed. Its melting point is 3,414 degrees Celsius. Some of its compounds are catalysts and it has variable oxidation states. Particularly the fact that it's used as catalyst and they have these variable oxidation states. Remember things like iron 2, iron 3 exists. These are our variable oxidation states, 2 plus, 3 plus. The fact that it's used in the Haber process as a catalyst, this is a transition metal property. And the fact that they have high melting points also indicates D. Petrol burns in a car engine to produce waste gases which leave through the car exhaust. One of these waste gases is an oxide of nitrogen. Which statement describes how this oxide of nitrogen is formed? So remember, you've got nitrogen and oxygen in air. They're quite unreactive gases, but in car engines you get very high temperatures, forcing the two to react, forming oxides of nitrogen. So that's why B is the correct answer. Which combination of chemical compounds can be used to produce the fertilizers shown? NPK stands for nitrogen, phosphorus. Use your periodic table to help you identify these elements. Potassium. So you're looking at these 4 options to see which one contains the elements we need. We need A. Which process does not produce carbon dioxide? Combustion of a hydrocarbon definitely does. It produces carbon dioxide and water if it's complete combustion. Photosynthesis, remember, produces oxygen and glucose. So that's why it's actually the correct answer, because it does not produce carbon dioxide, it uses it. Just to check C, reaction between an acid and a metal carbonate produces carbon dioxide, water and a salt. And respiration produces carbon dioxide and water. So between A, B, C and D, it's photosynthesis which does not produce carbon dioxide. Which substance is used as bleach in the manufacture of paper? It's actually sulfur dioxide, another fact you just need to learn. What is an industrial use of calcium carbonate? This is limestone, remember. It's used in building processes to make things like cement, mortar, and concrete. The answer here is C. 34. Propane reacts with chlorine. I'm just going to draw propane. It's a saturated hydrocarbon. It reacts with chlorine, which is a diatomic molecule. Which row shows the condition required for this reaction and identifies the type of reaction? So it's easiest if I actually draw what happens. So one of those hydrogens gets substituted out for chlorine. And so because of that, it's a substitution reaction. And you need the presence of UV light. Remember, phosphoric acid is used to make alcohols in the hydration of ethene, which is why this isn't the correct answer. The pie chart represents the composition of natural gas. Which sector represents methane? Natural gas is largely methane, so that's why it's D. Which statement describes the reaction between ethene and steam? So we just mentioned this actually, to do with using the phosphoric acid catalyst. So you do this reaction to make ethanol. So it's definitely not a cracking reaction, because that's all about breaking long hydrocarbon chains into shorter, more useful alkanes and alkenes. It's an addition reaction which produces ethanol as the only product. Yeah, that's literally what I've shown happen. It's an oxidation reaction which produces ethanoic acid. No, we haven't made ethanoic acid. It's a slow reaction producing ethanol and carbon dioxide. No, that's fermentation. The formula of a hydrocarbon is this. The equation for its complete combustion is shown. What are the values of X and Y? So have a look here. We have 5 carbon atoms. So we need a 5 there. And then we have 12 hydrogen atoms here, which means we need a 12 here. So it's 5 and 12B. The formula of an ester is this. Which acid and alcohol react together to make the ester? The easiest way of doing this is actually drawing out that ester. So I would spend the time doing this. Draw it carefully. There it is. And then just have a look. This end here would be going this way, is where your carboxylic acid would have originally been made. So remember, that's 4 carbons. It's a carboxylic acid, so it's butanoic acid. And then what's left over here, 3 carbon atoms, it's an alcohol, it's propanol. Molecule 1 undergoes a process to make molecule 2, Which row describes the molecules and the process? It's a matter of knowing that if you're talking about addition and polymerization, you start with a monomer and you form a much larger molecule, a polymer. These other things don't make sense. Cracking does not produce larger molecules, it produces smaller ones, hence why that can't be correct. And then with this C option, a monomer and a small molecule are the same thing, so again that makes no sense. And then with cracking, for option D, we would want a larger molecule up this end. The answer is B. And then finally, which structure represents a protein? So remember, your general structure of an amino acid looks like this. There's your variable group, has a hydrogen atom attached, NH2 on one end, C double bond O, OH on the other, and then a protein is just a polymer formed from lots of monomers joining together. So just to show you how that works. And then the molecule continues. So you're having a look down here to see what represents that link, that all-important link. You can't have the NH groups close together. You need it alternating like this. Because remember, that central carbon atom doesn't have two NH groups attached, so the answer is A.